Okay. Sorry, let me just mute this. There we go. Okay, well, welcome everyone to our September general meeting, specific to Sydney. Thanks again to all of our affiliates for participating. Thanks to our industry associations for all of your technical support. And thanks to our corporate members for your ongoing support. So for tonight's meeting, we have Sydney Water covering trade waste advice and questions. That might change a little bit. I don't know if there's an echo happening over here. Wait a second. I think it's all good. And then we have Grundfos talking to us about hot water circulating pumps, smart pumps. And then we have Greg Lelliot talking to us about embedded networks and some things to consider when designing embedded networks into buildings. Okay, so across to our committee report. So first of all, welcome to the Queenslanders who've dialed in tonight. We did send an invite to the Queensland HCAA committee, so that are going to forward around. So hopefully there's a few of you that have dialed in. If there are people who have dialed in and others who haven't, we will make this available on YouTube in about a week or so's time, so they'll be able to watch it there. So a reminder to members, CPD certificates are available online on the website, and so are member certificates, and your member number is on the front of each certificate. I'm just going to check something, sorry. I'm just hoping my voice isn't echoing. Okay, so since our last meeting, some emails that have gone out. Oh, let me just jump back.
There is a slight echo there, Nick.
There is a slight echo, yeah. I think it's coming from, I've got my iPad on. Let me mute. How do I mute it? Maybe I'll just turn it off. There we go. Is it still echoing, or is that better?
Still slightly. Still a slight one.
I don't know where it's echoing from. It should be all good now. Unless I change. That's better?
Yeah.
It's better? Okay, cool. All right. Okay, so yeah, so we had the diploma update. Rod, do you want to give a 10-second, because I don't have a separate slide for it. Do you want to give, because we had a few diploma updates, but do you want to give a 10-second overview on that?
Yeah, look, I'll be very short. Hopefully everyone saw the email go out. Look, unfortunately, diploma delivery has been delayed another term. The main reason for that is that there is a new training package that has been released by Artibus. What that means is that TAFE need to get all the documents up to speed so that they're compliant with the new training package. Obviously, that takes time. There was a lot of debate on how it was going to run, but we figured instead of starting students in the old package for the first term or two and then trying to transfer them in the new one was going to be a nightmare, it's much better to get the package up to speed first and then just start everyone fresh and move them in, and then it'll be seamless. So really sorry that there's another delay there. We're very conscious of the fact that we've pushed a few delays in, but we're hoping that it'll be going well. The intent at the moment is still that the Cert 4 for the people that have done their operations stream, they have a couple of subjects to finish. The hope is that that'll be in term 1 next year, and the diploma will be delivered from term 2 next year. So if you've got any questions, please send me an email, give me a call. Happy to talk about it and answer any questions for anyone who's keen to get enrolled.
Yep. Thanks for that, Rod.
No worries.
All right, and then so we've sent out AS3500, all versions have come out in draft form. Public comment is closed, but that was about 6 weeks ago. There was Rod also put out the desire for people to put their services forward to write the diploma. I can still hear an echo.
Yeah, it's only a little though. I don't think it's not offensive.
Figure it out after.
Yeah, I haven't received any great responses from that actually, which is a little disappointing.
Yep.
But if anyone does have some time available, look, it's not immediate. We've got a few things to line up with this new training package, but it certainly will be towards the end of this year. So if anyone does have some time and knowledge to be able to help write some assessments, that would be much appreciated.
And what subjects for people who might be interested?
Look, well, so we've done about half of them. Look, things like sanitary, trade waste, what have we got? Stormwater, pump systems. A bunch of those have been what we thought was completed that are now going to have a small review, but I'll take care of those. There was a few things off the top of my head, basically how to do a site visit. It's not actually called that, but that's what it's all about, what you need to look for when you're doing an inspection. We are still working on hot water, so solar and non-solar, fire hydrants, hose reels and sprinklers will need some work. So yeah, they're probably the key ones at the moment that I can think of if you're sort of strong in those areas.
And how many hours are they looking at? And what was the pay package again?
So the pay is $83 an hour. Most of those bigger subjects, like the fire subjects and the hot water, are around 30 or 40 hours allowance to prepare the documents. I think the site visits might be slightly less. It might be sort of 15 or 20. Mm-hmm. So, and there is a bit of scope to sort of go outside that. Those allowances were guesses very much at the start of this whole process.
Yeah,
we've had a few that have come in shorter than that, and a few that have gone over.
And this is anyone in Australia can put their hand up for this too, can't they?
Absolutely. We've already had Daryl Isles from Perth has helped out with the cold water subjects earlier on. Mm-hmm. It certainly doesn't have to be anyone in any particular state just because it's being delivered in New South Wales. It don't have to be in New South Wales.
Yep.
It's just help to get that technical content together, and I'll certainly help you with the formatting and how it's got to be laid out and what the documents are called and all that sort of stuff. That TAFE has a whole bunch of templates that we need to follow, so I can help with that.
Okay. Thanks, Rod. So the other one was Rod already gave an update on TAFE were being asked by the government to only allow enrolment into the diploma by someone who's already working in office, but that requirement was dropped, and that's created a lot of opportunities for a lot of people who didn't yet have a job placement. That's correct, isn't it, Rod?
Yeah. Look, there's a bit of a blessing in disguise from this new training package. If we had around about 80 people that wanted to enter either the Cert 4 or the diploma, and I guarantee you there's not 80 jobs available right now across the country. So I think we're still encouraging people to move into an office if they want to do hydraulic design, but it's not mandatory, which it was under this previous training package. So it takes a bit of the heat off on how that was going to happen.
And if you know someone who is interested in moving into an office, they can send an email to Rod at education@hcaa.org.au. And we did have one student contact us. We put a little post on LinkedIn. So he's looking at relocating from Perth to Sydney. So if anyone knows anyone looking for work that is in that sort of student role, then get them to contact us and we'll share their details with other members to try and create opportunities for them.
Yeah.
Okay, so then we had our, just so everyone knows, the general meeting invite goes out typically about 2 to 3 weeks before the general meeting, sometimes a month before. That will have an invite now for all of the meetings. So next week we have a meeting in Adelaide. The week after that is Canberra. So that first email has an invite to all 3 meetings. And then after that, reminders get sent out the week prior to that meeting. So a reminder went out last week for Sydney, a reminder will come out this week for Adelaide, and then the reminder will come out next week for Canberra. So the first invite will have all 3 locations listed, and then after that, it'll just be the next meeting only. So then we had an update on iPlex, which I'll touch on shortly. There's an invite to a seminar series that CIBSI are running. CPD invites. We've already been on the education, so there were a fair few updates on education. At the ABCB, we're seeking expressions of interest for sanitary plumbing and drainage pipe sizing verification method. So if you didn't see that, contact us and we can send that through. And then, although that may have been awarded already, and then there was our Zoom meeting that Rod held for us a week or 2 ago on education. So a pretty busy couple of months. So this is our current calendar for CPD events. So they're fortnightly, they're free. So if you're an affiliate member and you want to present, contact Emily. So inquiries at hcaa.org.au. We are putting together a bit of a guideline for how we want these CPD sessions run, but essentially every second Tuesday from 12 till 1. We're averaging around 30 members per meeting, probably about 40 book and around about 30 are turning up. And the requirement from the New South Wales government now is 25 CPD points a year. So running these fortnightly, we're offering around 25 CPD points a year via these lunch and learns. Then we also are awarding 2 points for a meeting. And then you also get points for reading magazines. There's lots of different ways to get points, but it should be relatively easy if you're active to achieve the points required. So you can see though we're booked out till Christmas, and but if you're listening tonight and you want to do a presentation into next year, let us know, and we're going to start to populate this calendar and list it on the website so people can see what's coming up.
Nick, can you trade Qantas points to get points?
No, you can't trade Qantas points, no, but flybys are okay. Yeah, we've got a partnership with Coles. So, okay, so the water demand investigation. So phase 2, we discussed at our committee meeting last week. I've typed up a bit of a business case for the committee that we'll probably forward to members once we're happy with it. But essentially the plan is to purchase a slightly fancier meter than what we already have that basically allows us to monitor the outgoing hot water flow, temperature and pressure, and then the return hot water flow, temperature and pressure. And then that data, part of this phase 2 is to sponsor Brendan from Deakin University. So the grad, he's going to do his PhD, and we want to contribute towards his PhD to have him continue to do this work. So what we've actually done is split phase 2 into phase 2A and 2B. So phase 2A would be to purchase one of these packages like this for one building, which is about $22,000 with all of the probes and everything installed. What this will do is, we believe it's the first time in the world that hot water data will be accurately monitored in line with cold water, so we can see live data of hot versus cold. We're also planning to go and dial down the cold water meter in the same building to give us 1 second readings instead of 5 second, to see how much having the data read every second instead of every 5 seconds changes the peaks. And then use that information to share with the ABCB, which Brendan is due to release his report for phase 1, which is the cold water monitoring on 4 blocks of units, to the ABCB this month, next month. We don't have an exact date, but hopefully sometime soon. And then hopefully that information will feed back to Standards Australia, and then possibly be in a future update of AS 3500. So what we're hoping to achieve by monitoring the hot is to see if there are any significant differences between hot water usage and cold water usage in a building, and whether we should be sizing the hot water differently to how we currently are. Yeah, what we'll do is when we get a bit more information on that, we'll forward it around to everyone. And we might also run crowdfunding to try and purchase more of these meters to put one on every building. Okay, so this was a bit of sad news that came through from iPlex in their South Australian plant, that they're no longer going to manufacture PVC fittings. Yeah, which is, I think for a lot of us, iPlex are a well-known and well-respected brand in Australia. So yeah, pretty sad to see them pull out of the market. But there are a few other Australian manufacturers still manufacturing PVC fittings in Australia. Yeah, so one of them is Plastech and Storm Plastics. So yeah, if you're an affiliate and you're still manufacturing in Australia, let us know and we can share that information around. So this one's what happened here was one of our members in Brisbane contacted us, who does a lot of McDonald's stores. Articulated drainage in reactive soils in Queensland is regarded as DTS by most of the authorities, or all of the authorities as far as I'm aware, whereas in New South Wales, fair trading consider it a performance solution. So what we have done is contacted Plastech. So thank you to Chris Ferguson from Plastech. He's helped us to prepare a performance solution for articulated drainage, where hopefully once it's listed on our website, you'll be able to download that, submit it to fair trading if you're doing a job in New South Wales. Articulated drainage is listed in the draft version of AS 3500, but because it's in the informative section, not the normative section, even when it is a referenced document in the BCA, which will be in a couple of years, we still won't legally be allowed to use it according to fair trading's interpretation, which will mean that even when it is listed in AS 3500, we will still have to do a performance solution until we get to a point where it is considered DTS or referenced in the normative section of AS 3500. So this is the advisory note from fair trading, which stipulates that it is considered a performance solution. So that's listed on their website. So just a screenshot for everyone. You can see option one is get a letter from a structural engineer, which most of them aren't willing to do. And option two is a performance solution. And that was released in 2016. So you can get that off their website if you want to know more. Okay. Oh, and this is the tab on our website where you can download all the current performance solutions. It's not listed for members only. Anybody can jump on there and download those. This was another rehash from last meeting, but just a reminder, Builders Professional Board, or the BPB, no longer exists. They're now fair trading. C14, C16, C15, C3, C4, all those terminologies are all gone, and they're now the terminology on the left, so hydraulic building certifier. This comes into effect more significantly 1st of July 2021, where for residential apartments, you will need to be listed on the Fair Trading's website or certified with Fair Trading. So if you're not aware of that process, contact me and I'll let you know what's involved to get accredited. It is fairly time consuming and expensive, but once you're on there, you basically pay your renewal fee each year and make sure you've got your CPD points. And there is more information from our previous meeting. So we do have a YouTube channel. There's only 11 people subscribed at the moment, but we have listed our last two online meetings on here and Rod's education meeting. So if you just go to YouTube, type in HCAA, you'll find the channel, and there's more information on the changes in New South Wales from our last meeting. There's also the presentation from Deakin University in our May meeting, which summarizes about 35 minutes in. I think it summarizes the water consumption monitored to date in those apartment buildings for those interested. Okay, so Rod touched on this before, but the diploma unfortunately was delayed due to COVID, like so many things, to start term 2 next year. There was the ABCB's National Framework for Building Practitioners. We have prepared some comments. We've prepared them from a New South Wales perspective. We've forwarded them to the Adelaide committee, and the guys in Adelaide have sent some comments back to the national committee, and then we've also shared our current comments with HCAA Queensland, and the HCAA Queensland committee are currently reviewing those, and they're going to share their thoughts with us as well. So if you're not aware of this, the main summary is you need to be diploma qualified to design anything over 6 floors. You need to be degree qualified according to the current guidelines to do a performance solution. And you need to be minimum Cert 4 qualified to design up to 6 floors. And this is a little wheel. So Cert 4, diploma, and then category 7 is an engineer. Okay, so the cadetships, unfortunately, Rod and I were looking forward to presenting the material to the cadets face to face tonight in Sydney, but that hasn't happened. But congratulations to Jacob, Petter, and Ty. So I'll just flick through. Rod can add some extra comments, but these are the packages that all the cadets got, plus they got an HCAA shirt and hat as well. But that's a little box of goodies.
Yeah, look, I was able to go out and deliver it to Jacob and Peter, but Ty being in Newcastle was a bit too far a trip, so I've mailed his stuff up to him. But look, all extremely grateful. Certainly the guys I've talked to all 3 of them numerous times now, and really quite excited about what they're going to do. And all very grateful for all the kit that they got wrapped up in that. You know, there's some Eskies backpacks, drink bottles, compendiums, notebooks, the pipe friction handbook, pens. You know, it's pretty good little package, I think. So they're all very happy, and wanted to thank everyone very much.
And for any affiliate that's listening who may not be aware how this runs, so we had how many people applied, Rod? About 20?
Yeah, I think it was 18 in the end.
18, yep. And so at the moment, we've got the 3 sponsors, HCAA, Ream, and Vega, you can see in there. But next year, if anyone's interested in sponsoring a cadet, get in touch with Rod and let us know, and he can let you know how it works. But basically, the aim is to subsidise the cadet for their TAFE fees, and then also help to support them through the first few years in the industry with job placement or advice or whatever's needed. Yeah. So thanks for all that.
The TAFE fees itself comes to what we've committed to is not the complete course fees. We've committed to $8,000 over the 4 years. That's assuming they're doing the Cert 4 and diploma together. So it's not the total course cost. If you're outside of New South Wales, 29 grand. We're not going to ask people for that much money, but it's certainly still going to help even if they are outside of New South Wales. But we've already got interest from Rehow for next year, but we'd love to have more. And if you can help out, then that would be awesome.
All right, thanks, Rod. Okay, so I've stolen these. Rod kindly put these together for us, but there's Jacob, and then we've got Petter, or Peter. I'm not sorry.
Peter. Yeah.
Peter. Okay. Yep. Peter. So I didn't realise, but it looks like she's Scott's son, I assume, from the. Scott's daughter.
Not too
sure. Okay. Well, maybe we can ask Scott that. But congratulations, and then Ty as well. So. Okay, so these were the draft standards that came out, but you can see we didn't get very long to comment. I think it was only a week or two. So that was, that closed 3 weeks ago, 2 weeks ago, depending on which one. So there were comments put in, and now the committee has to go and work through. I don't know if Dave Wood's listening, but I think there's hundreds of comments that were submitted Australia-wide. So they've got days worth of meetings to go through all those comments, close them out, and then possibly publish it again as another draft, or maybe publish it as a final version. Okay, so ABCB have launched a watermark awareness scheme. What we'll try and do is publish some of the content they've sent us on LinkedIn, possibly email it out to members, but just trying to educate the public better on what watermark is and why it's important. So yeah, just to let everyone know that's happening.
Wow.
Hot tap is running or warm water is running. Can you leave turn on both hot and cold? Hot off, cold off, in off position. Tap still running.
Nice.
All right. Yeah, so thank you to everyone who submitted the photos. If you've got a dodgy photo, send it through to me, or send it through to Em, and yeah, hopefully you get to see it up on the screen. So yeah, thanks to everyone who submitted those to me, and thanks to my mate Steve for the video. I was I think he found that on 3 or 4 basins in this particular facility. So yeah, there might be a few other people out there that might want to check the same thing on their next job.
Is that a hospital?
Aged care, I think. Yeah, aged care.
Yeah.
Wow.
Yeah. So we might take a 5-minute break, and then we'll kick off for our first meeting, first speaker. So thanks everyone for listening, and yeah, I hope that was informative.
Oh, what have I done?
Hey, John, if you just want to
Yes.
share your screen,
Rightio.
then it's all ready for you to go.
Sweet. So am I up there now?
You are.
Okay, when do I start?
You can start now. We are ready for you.
Okay then. Okay. Hello everyone. John McElwain from Sydney Water. I'd like to thank HCAA to give Sydney Water the opportunity to do this presentation tonight. Hopefully we'll ask all the trade waste questions you're asking. So what I've done is sent out an email to all consultants and to the president and asked them of some of the questions that you are wanting to ask tonight. So I've put together a presentation which will hopefully cover those topics. Probably won't be all of them, but hopefully what we'll do is this won't be the last time we'll be able to do these sort of presentations, because I believe that we should continue the form of discussions. So just want to give you a bit of a background history on myself here. I've been working with Sydney Water for 13 years, having plumbing background. So I've got a bit of a feel for both what Sydney requirements are and a feel for what Sydney, some of the trade waste plumbings are requesting. So hopefully we can work it together. I'll just get the next slide. Okay. Next one. Why are we going that way? Okay, topics of discussion tonight. We're going to look at installation of grease arresters, aged care facilities, childcare centres, and consultant questions, which are some of these emails that I had received. Wrong way. Okay, so first what we'll do is we'll look at grease arresters. So what we'll sort of work it out from this way. The location of the grease trap to be installed in a safe and accessible area for waste transporters. So what we're looking at is that grease traps are designed to be located in loading docks, back of shops, where trucks can easily access these grease traps and they can get their pump out lines clearly into them. For areas where there's no accessibility for the trucks to get to, we would ask to install pump out lines where the access for transporters cannot be achieved. So when you're installing pump out lines, we're saying that we do not permit connections directly inside the grease trap. This is not an uncommon situation. The problem with that, it only encourages transporters to just pump out the grease traps and not clean the grease traps and look at a physical inspection inside these grease traps. Their cleaning requirements for these transporters that they to pump out all the liquids, clean the sides of the grease units, and also clean the surge control devices on the outlet of the grease traps. So the next thing is what we look at is for a minimum of 1 metre unobstructed clearance above the grease arrestor. So this is to give the transporters and the contractors easy access to clean these units. Where you're installing grease traps that are above ground, what you need to consider is to provide an access platform. Now, these access platforms are to be installed where the grease traps are above a height of 1200. So keep in mind when you're installing these units that where you've got these locations and you've got a grease trap that's higher than 1200, you need to make sure that there's room for the platforms to be installed. So that's a very critical thing, because some of these units are installed in little rooms where they don't allow any access and to put platforms. Another point is ensure easy access to all grease arrestor lids. So where the locations are, that there is no obstructions or any walkways or pathways above it that may obstruct these lids. Ensure that the greaser rooms have adequate ventilation is not considered as a confined space. Now that's an interesting situation, because we do come across these situations where it does become a bit of an issue for transporters to come in and clean out these units, because then they were required to have confined space permits, which is an additional cost. So when you're sort of looking at these considerations, make sure there's adequate ventilations across these units. So what we've got here is just a typical drawing. The drawing on the left is what we don't want, and that's a direct connection to pump out line into the grease trap. And the drawing on the right is what you can see is a pump out line outside the grease trap with a cam lock fitting. Again, what we're looking at here is you can see these photos. These are some examples of where some grease traps have been installed where they don't comply. Height access above them on the right hand side, that's a nasty one. And there's typically no access to these grease traps. The one on the left, the one on the right, you can see there is access, but they've only got 450, which doesn't comply with our guidelines. So keep in mind, guys, when you're installing grease traps, that you're choosing devices that will meet the requirements in height-wise, because typically some basement areas can be shallower, and then you need to really carefully consider the grease traps that you're going to install. So keep in mind of that. Okay. So the next topic I'm just going to discuss with you is aged care facilities. So what we've found is it has been identified that new aged care facilities are now providing servery areas where heating food and washing plates are carried out at these locations. Pre-treatment will be required if these kitchens are discharging trade waste. So this includes serveries with commercial dishwashers and cooking facilities. Now, what we have found from Sydney Water, that we look at in the traditional setup of a nursing home, was what we found in the past is that where the main kitchen was the centre, and all the food was cooked from there, served out to the residents, and then the plates would come back, and then there would be a dishwasher inside these main kitchens, and then from there that they would discharge into a communal grease trap. So what we're seeing now and what we're hearing is that these designs now is that they're transporting the food from the main kitchen, reheating them up at these serveries, serving them to the residents, and then they bring the plates back to these serveries where the cleaning of the dishes are being carried out. So just be mindful that would be identified as a trade waste discharge. So that's why Sydney Water would ask that pre-treatment to be installed at those areas. Now, I know there's been a bit of a confusion out there. Kitchenettes designed for staff and visitors, and what we're looking at is they're just kitchens where they're just like a breakout kitchen where the staff can make a cup of tea, got a microwave oven in there, reheating a bit of food, and likewise for visitors. And look, they're not considered as trade waste discharge. They're just considered as a commercial kitchen, which is not, they're not discharging trade waste. So just bear in mind the fact we can consider that the serveries where there's commercial. So what we would suggest is the sizing of the grease trap is per the current guidelines. Right. Okay, the next subject I want to touch base is early childhood education centre. Again, another industry which is evolving, and what we're finding is now that these businesses are getting bigger, and what we found is that identified some early child education centres are now offering cooked meals as part of their service. So these centres are installing commercial kitchens, including commercial dishwashers, which is identified as trade waste discharge and required trade waste to be installed. So again, what we're sort of asking yourselves is when you're designing these centres, we ask you to ask the customer what type of food services they are providing. Now, we've come across a couple of them where we've asked for a menu and they've kindly provided it. So that'll determine what we've observed, that some of the meals that they are providing would require a pre-treatment to be installed. So again, a critical factor is what their menus are and what type of food they're serving. So just be mindful of that. And again, the size in the grease traps as per current guidelines, so that'll be seating. We are looking into the early childhood education centres as a policy and a process. And when we have any updates, we will inform you guys via the Sydney Water website. Okay. Okay. So, oh no, we'll go back. Sorry. Okay. Yep. So here, what I'll do is just touch base with consultant questions. So see, these are some of the emails we have received from yourselves, and we'll just sort of go through them. Okay, so one of the questions, common problems that Sydney Water finds are DAF units, and their lack of maintenance. So DAF units are installed usually in shopping centres with a grease trap requirements above 30,000 litres. So that's when you guys need to consider designing DAF units in these centres. Yes, what we have found that when we actually come out and do a site inspection, we would ask for a operational program to be shown to see that that's how they're managing it. If they fail to do that, that'll be one of their minimum requirements, and they need to ensure that they carry out these instructions, and they've got someone dedicated to manage them. So, next question I'm looking at, clarification of maximum size grease arresters. Okay, Sydney Water still only, our maximum size is 5,000 litres at the moment, and will continue to be that size till further notice. Sydney Water will allow in-series connection tanks, but up to still the capacity of 5,000. So what we're looking at is you can have a 2,000 plus a 2,000 plus a 1,000 litre unit. So in regards to grease traps, currently it's 5,000. I have heard a lot of, yes, we are aware that there are bigger units out there. And look, the current situation is what we are standing by is 5,000 litres till further notice. Right. Okay, next one we're looking at here, question, are you looking at increasing allowance of grease for certain shops, particularly Asian shops with 3 woks and so forth? Look, we haven't made any current changes here, so they're still staying with the current guidelines. We will update you when there are changes made. Again, in that situation, our group of trade waste officers, we currently get together and we have formed a committee where we are sort of looking at these situations at the moment. So when we do make some changes, we will advise you of any changes through our website. Next question. Again, I know this is a common problem, effectiveness of heat tracing on grease waste lines. Look, Sydney Water doesn't have any stances on that situation or any guidelines on that. And look, all Sydney Water would recommend that installing grease traps as close as possible to the outlet units. So, okay, another one here. Question here is from the interconnection of grease arrest events. Yes, we are currently reviewing this grease arrest event sizing for multiple grease trap arresters. Our technical specialist is currently putting the paper together, which is then going to be reviewed by our seniors. And then once this has been finalised, we will sort of relay this information through our website. And I believe that we will sort of, through your organisation, we'll give you updates of where we are up to with that. Would you recommend, again, the next question, would you recommend locating grease arresters in ground adjacent to retail food seating area? Okay, interesting question. Look, again, first and foremost, Sydney Water advises locate in a safe and accessible for transporters. So that's our first paramount reasoning for that. So it's got to be safe. Take in consideration when they're talking about putting in the retail seating area. I guess one of the points is that you've got to take in consideration if there's ever a spillage or any blockages, there might be an inconsideration towards the tenants of inconvenience of smells, and so take that in consideration when you're designing locations of grease traps. And again, ensure local location meets health and local council requirements. We have found that some plumbers will come up to us and say, "Are you okay with that?" We would sort of say, well, if it meets health and local requirements and it does meet our guidelines, we will say it's okay. But if the council and health authorities can overrule our ruling there in that situation. Okay, next one. So again, another question we ask is we're asking for inquiries. So what I want to point out here, ensure all trade waste application inquiries for a project are submitted through tap-in via Sydney Water website, okay? So if it's for a particular project that you want to make inquiries about, email it through Sydney Water to our via tap-in. Now, yes, we understand our tap-in application system is very limited to what information can be provided. That is being looked at currently, and there's going to be an upgrade with tap-in. But what we would do is in that general information, provide some information that's saying you're requesting for some clarification of some for this particular project. What will happen is the tap-in, so your case would be assigned to one of our business customer representatives who will take it on, and he will come in contact with you via email, and then from there you can then communicate through emails with drawings and stuff like that if you of any inquiries you can. Now, if it's a situation where it's a bit above our recommendation or guidelines, we would then pass it on to our technical specialists to review the situation. Again, for general inquiries, you can send an email through businesscustomers@Sydney Water. So that's just a general question. It's not relating to any particular project. So you can send your inquiries through that. And what I would advise is to, where in the text, just write consultant trade waste inquiries. So this will help our office people to sort of then redirect these emails to the relevant BCRs, who can then review your request and then follow up with you with a response. So, and then so any further information can be found on our website. So yeah, so if you, I don't know if you're all familiar with our website, it's got plenty of information there. And just giving you a heads up too that Sydney Water will be updating our website, hopefully a bit more easier to use and to be fit for you guys to use and to access information. So, and that's all I've got for you. So I guess, Nick, is there anyone wants to have any other questions or anything like that?
I might rattle off a couple of questions I wrote down, and then other people can jump in. So you mentioned safe access for a truck. Do you guys have a guideline on how big that truck might be? And
No.
yep, okay. You used to have a trade waste guideline available on your website, and then it got taken down. Is it back up? I haven't looked for a while. Is it back on the website again, the guideline?
There is, look, the current one I would be using, there is a document there called Retail Food, Plumbing for Retail Food. And that basically covers all our minimum requirements for trade waste. And as you can see there, it's got a sizing at the back there. It sort of gives an indication of how to size the grease traps. Now, I do take on board of what you were saying about some more information. Yes, there has been some material taken off. And as I alluded before, that we've been told that the website's going to be updated, and we have made, as a group, made requests that some other information should be installed on the website, so you guys can easily access it rather than...
Yeah, because you used to have about a 40-page PDF that I have a copy of on my computer, but I'm pretty sure you took it offline. We might list it on our own website for anyone that doesn't have a copy until you guys publish something newer, because it is a good document. So you mentioned the 1 meter depth for the grease arrestor minimum. So it used to state the same depth as a grease arrestor. So if the grease arrestor was 1.5 meters, you had to have 1.5 meters above, but you guys have now dropped that to a meter is all you need to achieve. Yep.
Correct.
Just as, and that was more of a reminder. I think one of our members sent that through to us. You changed that 6 months ago, did you? Around about then?
Yeah, well, look, again, it was, we could see that those measurements can't be achieved in construction sites or in basement levels when you've got a minimum of, when you've got a height level of 2.4. So that would have been hard to achieve for a majority of the installation of grease traps that are above ground. So what we've done is that we've considered that when we say unobstructed, it's just so for the transporter to get easy access to look inside there and to properly clean the grease trap unit. So
Okay. And then my query on the truck before, it would be good for you guys in Sydney Water to throw that question around, because I've
Yep.
seen the grease trucks and they vary a lot in size. So
Yep.
we would like to get some guidance, because if you have one in a basement, what do we deem safe access as? If we don't have a guideline to work around, yeah, it's a pretty broad brush there.
Well, look, I guess the thing is you've got to take in consideration there, Nick, is when there are some mini trucks that can go in and out, and look, a lot of guys would sort of consider that as an accessibility for a truck. But when you've got large volume units, you've got that a long, it's going to take a long process and could be a costly process for the customer at the end of the day. So hence that's why we sort of look at, at putting in pump out lines to above ground or to a loading dock, suitable for these guys to pump it out.
John, just on that, when you have those mini tankers,
Yep.
do you know what storage capacity they typically are? Would they be around 2,000 litres at a guess?
Yeah.
So if you've got a 5,000 litre in a basement, I think that's what you're getting to, right? That's a 3-trip exercise just to clean that out once every quarter.
Yeah, and look, and then what you're doing, if you're installing a pump out line, then you're not restricting the customer to transporters, because then it leaves customers only to a short list of contractors that can actually carry out those processes. So that's one thing I suggest to be mindful of that. And it's just sort of it leaves the customer peace of mind that it doesn't matter. He doesn't have to be cornered in to choose a particular transporter.
All right. One other question I had. So you mentioned this maintenance program, which the plumber would be responsible for, but in our world, we can get dragged into these things. So is there a guideline on what this maintenance program constitutes? And is there
This is for the DAF?
Yes. And is there a point in time that must be submitted, just so that we're aware, so that if, we don't find out about it on a job?
Well, I guess when you're getting up to the point of design there, Nick, if you are installing a DAF unit, I think part of the instructions would be that as part of the process that the customer would be reminded that they would need to employ someone to manage an ongoing process with the DAF, and that they're aware of how they manage it. Now, these units now are only basically at central, as you said, major shopping centres. We do have these processes in what we call our major customers, so industrial customers, but as part of, we'll probably adopt the same sort of process of what our industrial customers do, is that they provide a operational plan, and they can show us that they're fully confident of operating these devices. So, and able to maintain them. So again, it's one of those questions of what we're looking at for further, for future reference. We're sort of in visualizing that these centralized pre-treatments, we will be conducting more inspections on the site. So it's basically making the customer aware that we could turn up at any time to do a spot check to make sure that the devices are operating properly, rather than just turned off and walked away. So,
okay. So we've got a couple of questions have come in. The general hose length from the grease truck, do you guys have a rule of thumb?
No.
Okay.
There's none there.
I've been told 20 meters. If I'm going to I've been told about 20 meters is what they don't really like to go too much further than that, and about 4 meters vertically. Someone else might have another comment to throw in. Then does a grease arrestor need to be filled with water once serviced? I'm not sure where that question's come from, but obviously it's come up on a job.
Yeah, well, that's nothing that we imply. I can understand that situation, because clearly if you've got a vessel that's empty and then the ground behind underneath it gets wet, and it may lift it. But no, we don't have that. We don't have a guideline with that to be filled up. It's a very rare situation, I guess, because if it's a kitchen that's being used constantly, it would fill up in no time, those units.
Nick, this is Howard Christie here from Howden. Can everybody hear me?
Yep, we can hear you.
Yeah, look, thanks, John, for the conversation tonight. Look,
Sure.
I have a matrix of vehicle lengths and widths and weights for anyone that wants it for trade waste vehicles, ranging from the 2,000 litre capacity all the way up to 12,500 litres, and sizes, width and height, etc. The method you're talking about before is sending a 2,000 litre truck down into a car park and decanting back to a larger truck parked up on the curb. That's done quite regularly over the Sydney region, CBD. It's called decanting. Certainly hoses. Hoses are often left in when there's a remote pump out situation. Some of the trade waste carriers, including Howden, will possibly leave a hose down in the adjacent to the grease arrestor enclosure. If it's in an enclosure or a chain wire or either freestanding, they'll leave a hose down there regularly. So they won't be carting hoses down. So the operator can just wander down into that car park region and hook up his hose to the cam lock fitting. And also from the remote fitting in the loading dock or curb, they have another hose there. I'll also have a matrix on lift capabilities of vacuum trucks. Basically, our newest vehicles for clean water have a 9-metre lift capability for clean water. But by the time we throw a percentage inefficiency for grease waste and also catering for older trucks and vane vacuum pumps, my recommendation or Howden's recommendation is around about 6.5 maximum to 7 metres static vertical lift, for a vacuum truck to be able to do. I also have a matrix of vertical to horizontal capabilities for the pipe work as well. 75 millimetre OD pump out line as stated by Sydney Water.
35 or 75?
Pardon? Nullable.
I think it's 75, minimum 75 mil.
That's correct. And the last thing, yes, there used to be a requirement for filling up grease arresters. It dropped out with maintenance, dropped out about 7 years ago when we had a major drought situation, and Sydney Water changed the requirements at that stage to no longer fill up grease arresters after pump out because of the drought situation. So the current standing is you don't have to fill up a grease arrestor after clean out, but I highly recommend it because when it fills up, the grease just moves straight through the whole system, while it's filling up. So not a good option not to fill it, but you don't have to. Thanks, guys.
Howard, Rod Ware here. Those documents you just mentioned sound quite good. Would you be able to forward those to Nick so that we could distribute those to our members?
Oh, Rodney, I think I could for a small favour somewhere along the line. Certainly the next job would be good.
Okay.
Yeah, we can fix that up for you, yes, Rod.
Awesome, thank you.
Thank you. There's a few other questions flowing through. What we might do is, if you have any more questions, email them to us and we might compile a list of questions and answers to John so we don't drag things on too long. The other one I wanted to touch on quickly, there is a grease standard that was being written by a committee with Standards Australia. Kate Jennings, I can see her in here actually. Kate, do you have an update on where that's at? I know it was sort of on hold.
Hey, it's still ongoing. The meetings have just been, a couple have been put on hold, just as everything's getting worked out with COVID. But it's tracking along, but we're getting into the meaty bits now with sizing and performance testing and all those sorts of things. So, I think the next few months will be interesting for sure.
Okay. All right. Well, we might, when we know a bit more about that, we'll let members know. And then the other one, we've got Paul from South Australia. He's asked the question if Sydney Water are collaborating with any other authorities around Australia, and whether we could put you in touch. We've got Adelaide Water talking next week, Paul, in Adelaide on trade waste.
It's SA Water, yeah.
Yeah, SA Water. Yeah. So I think there's probably a fair bit, John, that you could share in that space. But again,
Yeah. What I was going to say, Nick, is like when you got questions like that, if you compile them and then you can send them off to us, and then we'll get back to you with what the responses we can, and probably encourage that too, because it's sort of I believe it's we need to have a bit more of a healthy relationship in communicating, because there is a bit of some issues out there that's a bit iffy. So a bit of clarity is great. Yeah.
Okay. Well, I really appreciate you coming along tonight. And
thank you for the time. And hopefully, like I said, we're more than happy to sort of continue on with these discussions at these sort of forums. That'd be great.
Yep. All right. Thanks a lot, John.
Thank you, guys.
Thanks. Have a good night. Okay. So we've got Patrick and Nicholas. If you guys want to take over the screen and run us through Grundfos smart pumps, if I've got that correct.
Hi, everyone. Hi, Nick. Hi, everyone. I'm just
Hey.
So, this is up here. Yeah, is that one there? This one. Oh, this one here. Okay. No, this one. That one. Yeah. Not too far ahead. No, wait. Sorry. So we have two screens here.
Yeah, down the bottom of it. Oh, you got it. Yep. We're up now.
Okay, awesome. Sorry, there was a couple of copies open there. So.
All right, I'll leave it to you guys. Thank you.
Okay, thanks, Nick, and thanks to the HCAA for allowing us to have this time. My name's Patrick Sweeney. I work with Grundfos in New South Wales, and I have my colleague here, Nicholas.
Yeah, I am Nicholas Arboleda. Thanks for having us today. And I'll be presenting in 2 weeks from now, but just wanted to share with Patrick and maybe assist with some of the technical questions today.
So we'll get started. Let me see here.
Yeah, so we will be discussing today, the main topic is circulators in hot water circulator systems, especially we were discussing intelligent pumps and why should we be moving to intelligent pumps compared to the traditional approach.
Yeah, so we'll start off with just your standard pump that's currently in the market at the moment. Just bear with me.
Sorry.
Oh, there we go.
Okay.
So yeah, typically you've got a fixed speed pump that's currently supplied into Australia at the moment. These have been around pretty much since 1970s. Grundfos became a major player in this market back then, and currently we do about, in all types of circulators, about 60,000 units a day. These type of units, they're typically powered up and run for 24/7 at the same speed, using the same amount of power, irrespective of demand, and operate with minimal intervention. In the industry, they're generally, and it's a kind of a term that's applied to all fixed speed pumps in the industry, they're regarded as dumb pumps at this stage. As they don't have any energy index, it is not possible to actually use these style pumps in circulating hot water in Europe anymore. It's generally just for Australia and the Asian market that they're using. To look at a smart pump, we'll just go through the features of them first. They're essentially a problem-solving machine. They have built-in sensors such as a temperature sensor and pressure transducer, and that takes information out of the system and helps to optimize performance of the actual pump. They also have the capability of setting various thresholds on them to protect itself through alarms and warnings. So you can set temperature limits, flow limits, pressure, voltage, under voltage, that sort of thing. And most of the optimized performance is actually done through the VSD that's built into the pump itself. They also have the capability of communicating directly with your SCADA systems, Modbus, Profibus, those various ones. You can get your troubleshooting information from them, so straight to your remote center, and it will tell you what's wrong with the pump and what kind of corrective action is required. They have also included what you call algorithms-based programs, and these allow for our Grundfos programs for adapting the pump to the actual demand of the system. They have set up within them an easy commissioning platform where you can actually go through step by step and set the pump up exactly with the controls that you have in mind. Saves quite a bit of labor time. Having all these in the system, pump itself reduces the actual requirement for having balancing and throttling valves. And the current I suppose, undertaking that we're doing at the moment is fault prediction, where we can actually predict the actual faults in the pump before they arrive, which means that we can get some preventative maintenance done to the unit and there's no catastrophic failure.
So, as an example here, this is a Magna 3, and it's able to diagnose and propose solutions when one of the thresholds that we have mentioned is exceeded. So, for example, can detect dry running and say, okay, you need to prime your pump, or it can detect high temperature. So it will tell you you need to check the wiring or the voltage. So that's why the next step in intelligent pumps will be that the pumps will not tell you what to do, but they will do that themselves.
Thank you. What you get in the actual pump itself, it's all about communication. There's a number of inputs and outputs that are available, so you can interact either directly into the system itself or into your communication system. There's a facility within the pump head for you to be able to put in your optional SIM modules to communicate with the likes of Profibus, Modbus, BACnet, that sort of thing. Examples of the kind of information you can get are your flow, your set point pressure, what water temperature, the number of starts, the number of run hours that are on the unit, power consumption, that sort of thing. When they're all set up, a dumb pump or a standard fixed speed pump would generally cost, say, $1,500. For an intelligent pump, you're probably looking more at around $3,000. But the savings in the installation will probably compensate for that, because you don't have the need for throttling valves, which can range from probably around $200 to $2,000 depending on the system. You also save on engineering and commissioning costs as well, which could be up to $2,000. And the pumps already have a heat meter, if required, inside the pump, which enables you to manage your heat use. And all you need to do is apply another temperature sensor to the actual pump itself. Once the pump is in and installing, there's also the added savings that you made from the energy savings of the unit. Generally, they have a return on investment of around 2 years. After that year, or after those 2 years, then you're actually saving money. And say after 10 years, it's $4,000 that you've saved. If you've got 10, 20 of these units installed, it's actually quite a sum of money to be saving in a building. So you can save up to about 75% at the moment, just on its running cost. In Europe, they have legislation now that has brought in energy indexation of what's allowed into the marketplace. Using as a reference a standard fixed speed pump as a year 100 index, over time the EU has lowered the requirement for these units to be allowed into the market. So currently the Magna is well ahead of the, or the current intelligent smart pumps are well ahead of the market, and can provide savings of about $6,500 over a 15-year period per unit.
Yeah, I think it's important to point out here that the main source of these savings is the load profile that happens in a heating system. So as you already know, systems that operate with water, like water-based systems, they will be running 90% of the time at 10% of the peak load, say the design load. So it means that a standard circulator will be running, as we said before, 100% of the speed and 24/7. But an intelligent pump will be adapting to those changes in the system, and that's where you start to save money in terms of energy consumption.
Yeah. So back in about 2009, the EU put motors and circulators as the main drivers for this indexation. And they've later, in around 2012, added water pumps, and in 2015 they've added wastewater and clean water. So it's definitely an initiative that's been well driven by the Europeans, where a lot of the manufacturing of these units is done. So to give you a typical case study, in Australia, it's not a huge market for circulators, but typically it's estimated that demand is around 6,000 units per year, which generally on a fixed speed pump would generate around 47 million kilowatt hours per year. And the carbon emissions from those units would generate 42,000 tons of CO2 per year. Potential savings with the system integration and the energy efficiency of the units is around 75%. So that would work out to be around 35 million kilowatt hours, or 32,000 tons of CO2 per year, which, just to put that into perspective, that's about the size of what a town like, or a city of size of Bathurst would generally use in a year. Is that much CO2? So if you're taking something like that out of the system every year, yeah. The technology is not just applicable to circulators either. It's also available on most of our CBS booster sets, and yeah, it's pretty much the same points that we'd like to get across, which is the high quality and no warranty dispute. So all the controls, the pump and the motor are all put together, so you don't have a guy that's made the panel arguing with the guy that's supplied the pump. Everything's into one box essentially. The reduced maintenance and downtime as well available because of the redundancy that's available in the motors, by being able to have multiple sensors into each unit, and for those to be able to speak to each other as well. You save on the wiring up of the units, because they can communicate through Bluetooth as well as your BMS systems. There's also some features available where if you have interruption in power or reduction in power, that they're able to notice this and respond to it, and not be damaged, but still be able to provide into the system a level of support, water support. The commissioning is fast and easy. No additional control is required, and it will be pretty much the same with these units as it is with the circulators. CRE compared to a CR, nearly twice the price, but when you add an external VSD on, the controller PLC, control panels, additional accessories, you're looking at pretty much their power on par, and then you start making some savings on the actual energy itself.
Yeah. So behind us, we have a few examples of what we have been discussing during the presentation. So we have one of the Magna 3s installed as a dual system for hot water recirculation. It's the same that we have on the screen on the presentation to the right. And the other one is the traditional installation with two UPS 20-60N. As you can see, the main difference is that the traditional system has a controller, and with the intelligent pumps, all this control technology has been moved into the pump itself. So now you have the VSD and the control and the inputs and outputs and all these protections. Everything is integrated in the pump, and they have the capacity to communicate to each other, between each other, to operate as a duty standby or as a cascade operation, as in the one that we have in the screen, that is the Hydro Multi-E. So this intelligence is taking us to integrate solutions where you don't need an external controller, and you don't need that much wiring, and you're saving in some accessories, especially, for example, balancing valves. So in the end, everything is, you can compare prices. You can say, okay, this system is, yeah, it could be, seems more expensive as an initial investment, but it paid by itself with all these savings that we have been explained during the presentation.
Yeah. So, and that's the presentation finished. Nick, if you want to do some questions and answers, maybe.
Okay.
G'day, gentlemen. Greg Lelliot here. I've been involved with lots of pumps over the years, and I know that with the old UPS pumps, one of the biggest problems that we had was running them dry. Either the building would turn off the water supply and forget to turn off the pumps. Do these pumps have any form of dry isolation? They do, yeah. So if they recognise not only that there's dry run and shut down, they'll also send you an alarm to say that it's dry run as well. That's fantastic news, because I think there'll be a lot of people in the embedded hot water market that will be clamouring to get hold of these now, because it's one of the biggest problems they have is recirculators having shorter lifespans because of damage done from running them dry. Yeah.
Yeah, it's quite important what you mentioned there. And so you can define a threshold, as we mentioned earlier, and say, okay, we have this issue, for example, dry run, send me an alarm, disconnect the pump or stop the system to protect it, and then someone can come and service it or prime it and solve the situation.
I wish I would have had one of these a few months ago. It would have solved a big problem I had down in Melbourne.
Yeah.
All right, thanks for that, Greg. That was a good question. The one I had.
Now, Tristy here. Is there a minimum head? But the UPS 2060Ns have got a minimum head of 4 meters requirement, and that's often what causes the installation to run dry. They're put on a tank system, they don't work. That's why they preferably be put on the bottom of a building. Are these Magna's got a minimum head requirement?
Yeah, they have an MPSH curve. So yeah, I mean, we need to calculate what is the minimum requirement at the suction of the pump. But yeah, it depends. As you say, in each individual case. If you have them installed in the roof of the building, you need to pay more attention to the pressure at the inlets. But if they're installed in a basement, for example, so yeah, you wouldn't have any issues.
But you can also have a limit exceeds function set up in them as well. So if it does go below a certain limit, it will turn the pump off. And it may try, you can have it set up that you can have it try again once the pressure builds back up in the system again.
Yeah, the UPS had a dedicated 4 meters minimum head requirement. Yeah. Otherwise they weren't warranted or, at all. So there's no standard, there's nothing standard on Grundfos installation requirements saying they must have 4 meters head, or 3 meters, or 1 meter, or
on the UPS.
On the UPS, it's 4.
Yeah. On these ones, there's nothing. No.
Nothing. Okay, so there must be something. So yeah, so they can't run without any head on them.
Yeah, that's what I said. So we need to calculate the MPSH available in the system, and that will tell us what is the minimum pressure that you need at the suction, at the inlet.
Yes, if they're coming off gravity hot water systems, then they don't have a head on them very much at all. So that's important. Thank you.
Yeah, no worries.
Okay. The one question I had, you talked about ESD in Europe, but is there anything you're aware of coming out in Australia anytime soon on ESD and pump usage?
Yeah, I think that's a very important question, because it seems that we are about 10 years in Australia. We're 10 years behind compared to what the legislation is, the current state of the legislation in Europe. So for sure, there will be something that will make us move in this direction. For example, what they did in Europe is that they defined the energy efficiency index for circulators, and they defined some targets to meet for every pump manufacturer. So by 2015, they said, okay, every manufacturer has to be below a 0.23 energy efficiency index, and as you can see here, the Magna 3, for example, is a pump that is 0.18. So
are you aware of anything happening in Australia right now, so that, let's say, in 2 years' time we have to comply, or that as pump manufacturers you're not aware of any movement by the government to mandate anything here?
No, I think a lot of it's actually done by businesses themselves that just look for audits to be done.
Okay.
And so that's probably the main driving force at the moment that we're aware of, or that we find it.
And so the other question, so the percentage of these pumps sold versus the standard UPS pumps, what percentage difference are we looking at?
In Australia?
Yeah, in Australia, yeah.
They're very low. There's a very low uptake on them at the moment.
Are we talking like 2%, 5%? What's the...
Single digits, I'd say.
Yeah, it has to be less than 2% at the moment.
Okay. And one other thing, just as a personal comment that I think is missing, is Grundfos is a well-respected pump manufacturer in Australia. I think all of our members would know Grundfos, but from a New South Wales perspective, I'm not sure about the other states, but I think our dealings are more with pump suppliers and manufacturers, and it would be good to see more interaction between a Grundfos rep and consultants in New South Wales to give us some of this technical input, because quite often we're just dealing with one of the retailers that's reselling your pump. That's right. And often those pumps get substituted. I've specified this pump on 20 jobs and it's never gone in on one, because everything goes DNC and the plumber puts in whatever he wants. But it would be good to have a bit more interaction with you guys outside of tonight's meeting, and maybe get you guys to forward us your best contact so we can forward that to our members, so that they can send you emails direct rather than going to a retailer. They can deal with you guys direct on some of these questions as well.
Yeah, look, that's probably something that we've recognised ourselves, particularly over the last year, is that sometimes we sit behind dealers too much, and we've got very little visibility actually in with consultants and in with plumbing companies and that sort of thing. So there is a bit of a drive internally to start having a bit more visibility in the marketplace, that's for sure. Yep.
So of these two email addresses up here, we can email either of you, or Yep. Okay. All right. No, that's good to know. So
I think the other good thing about these pumps is that you can avoid unintended consequences with high velocities in the return pipework. I actually attended site to review a project where there was some other condition occurring, and we were asked to undertake a velocity check. And the fixed speed pump was actually creating a greater velocity in the return than what the DTS provisions provided for. And it was an unintended consequence from the designer who had written the correct flow rate. But of course, when the pump was selected, the system curve wasn't checked against the pump curve. And of course, the flow rate increased because there was no balancing valve on the outlet of the pump. But with these variable speed drive pumps, you just set the Q. It really is foolproof. And then all valves also supply some really great constant flow variable pressure balancing valves. And a variable speed drive circulator in conjunction with those is just so easy to design and so easy to commission, because there's no setting of manual balancing valves. The balancing valves aren't pressure dependent, and Q is super easy to calculate based on the heat loss. So my personal opinion is I would be using variable speed driven circulating pumps and constant volume variable pressure balancing valves every day of the week.
Yep.
The only instance is on very, very low flows, the Magnums don't quite jump down as low as the old fixed speed. So then I'll fall back to a fixed speed, but it has to be a very small job.
Yeah. Yeah, they're only made from 32 mil upwards.
Okay.
One special version 22.5, but we usually don't keep it.
Yeah, we don't
Australia.
keep it here in Australia. Yeah.
All right. Well, thanks for coming along tonight and sharing with us. It was very informative. I'll get your details and we'll forward them to the members.
Perfect, yeah.
And you guys are responsible. So what about Adelaide and Canberra? Is there a different contact you can give us?
Yeah, I think there's a different guy. Mark is looking after Adelaide. I'll find out. Nicholas and myself will be doing Canberra as well.
Mm-hmm.
Okay.
Yeah.
Yep. All right, it's good to know. Okay.
Don't forget the Queenslanders.
Yeah, and the Queenslanders, yeah.
I'll find out about Queensland as well.
Cheers.
Yeah, we can give you the contact for every state.
Yeah, that'd be perfect. Yep. Thanks, guys.
And Terry.
All right.
Thank you for having us.
All right. You want to take over, Greg?
Yeah, not a problem. If we're all good for me to share my screen.
Stop. Okay.
Rightio. I'm trying to get this to slideshow. There we go. Well, hi everyone. I hope you can all hear me now. We're all good?
Yep. Good.
Yep. We can hear you.
Yeah.
I'm not sure if everyone knows, but as of about a month ago, my time with WinConnect ceased. So because of that, I did resign my position on the executive because I was no longer an affiliate. But thanks very much, Nick, for inviting me along to run through some design issues that we were coming across in embedded hot water systems. Luckily for me, in my last 4 weeks of leisure, I've had the opportunity to talk to quite a few other players in the embedded hot water game. And it turns out that they've all got the same problems. So tonight I'll run through a few of those and see if we can help those that are looking at designing some systems with embedded hot water. One of the biggest problems with embedded hot water is there's a whole heap of different embedded suppliers who do things all differently. But this presentation is basically a fairly generic one. And really, if you're looking at being involved in a project that has an embedded hot water supplier involved, you really need to get clarification on them on what they do and what the plumber or the builder has to do. But there's currently several different types of embedded hot water systems, and while most of them are similar in layout, they do have an impact on the building that can, based on the service provider required, it can change what the plumber has to do and what he doesn't have to do. When I was with WinConnect, and I think most of the other embedded suppliers have something similar, the models that are offered normally are fully serviced hot water, where the EN supplier pays for the hot water plant and installation, the hot water meters, which are given to the on-site plumber, and they come along and install the AMR data collection hardware and software into the building just before PC to collect the data from each meters. There is also a bulk hot water option where the developer pays for the hot water plant, and the EN provider covers the hot water meters and the AMR. There's also a hybrid service model, which is basically where the developer installs a hot water plant with his builder and plumber, and then it's purchased back from the developer by the EN provider before practical completion. There's also another option, which is quite common in Queensland, but not that common in New South Wales. I've got a funny feeling it will be from talking to some of the embedded suppliers in the last few weeks, but that's where the developer pays for all the components, and then a billing agent steps in and spreads the cost of all the gate meters across all the occupiers at the meter tariff, and a small fee for collecting the data and distributing the bills is charged to each of the occupiers. So you'll see a bit more of that in the coming years. So What are embedded hot water systems? They can be various depending on the EN provider. Normally they are a gas-fired instantaneous centralised system, either internal or external, but they're also now going into commercial heat pumps in a centralised system. Some of them have preheated, solar preheated gas-fired services. Others also have heat scavenged from HVAC for any of the above plants. And if our friends are online from Steve Eltron, I better put this in here as one of the embedded suppliers said that they were interested in, or they were using three-phase electric instantaneous in each individual unit, which then removed the need to recirculate hot water. So you only had cold water feed, but this you need to get confirmation from BASIX, or do your BASIX report to see if you can fit that in. One of the problems with a few people in design is because they look at it and say, well, somebody else is paying for it, I'm going to create the most complicated and expensive system that I can find, because that's what I think will be best for me, easiest for the designer. Well, the EN hot water providers, they've got a limited budget, so you've got to be careful, because at the end of the day, if it exceeds their budgets, then they're going to start knocking the developer up for money, and then the developer gets upset. So their budgets are high but not limitless. Changes in an embedded hot water system compared to what we used to look at with Gemina. Of course, Gemina in the old days had individual gas meters in each apartment. With embedded hot water and gas networks, the meters have all been removed, and it's an unmetered supply into each apartment. Now that's normally only for gas cooktops. If you've got any other appliances in there, apart from a bayonet balcony for a barbecue, which they classify as a cooktop anyway, if they're cooking on the barbecue, chances are they're not cooking on the cooktop. So there's no extra charge on that. But if you're putting space heaters in or bayonet fittings for space heaters, you need to discuss that with the EN provider. Most of them don't like it because those heaters can be run 24/7, and that basically they're getting their gas at the price of a cooktop. So it really can throw the profit model out for an EN supplier.
Greg, another one, sorry, just to interrupt there, another one we've come across is spa baths on penthouses.
Yep.
Definitely no go with embedded networks.
Well, with embedded networks, if it normally comes to spa baths and even in penthouses, a lot of penthouses, they want their own space heaters. Normally in those circumstances, what the embedded suppliers would normally do would be to install a gas meter, and they'd put it up on the roof. Yeah. And they'd say, you know, you run your gas up to your roof, and then you run your gas down for your spa heater and your space heater, and you get charged for the gas as well. And normally that's where that's one of the rare places you will see embedded network suppliers go, yeah, not a problem, as long as we can get a meter up on the roof and a gas line back into the penthouses, which normally isn't that far. So, but we've had quite a few developers that have said, we want gas space heating in every apartment. And we say, well, listen, that's really going to be difficult to do it unless we slap a charge on everyone for 24/7 and say every day you're going to pay this extra money to cover the fact that you could turn that space heater on. It's no way to meter it because you've scrapped the meter cupboard, and it starts to get very, very difficult. But I mean, in New South Wales, it's not really a major issue. We found that most of these places have reverse cycle air conditioning, and a gas space heater is purely for an effect rather than anything. So, it's a rare occurrence, but it does happen. The big gas problem is with retail, because a lot of residential buildings also have retail involved. And normally the best way to get around that is to have a gas supply going to residential hot water and gas space heaters. And then, but before that, VBM put on a service line, and that can be run to the retail. And they can, normally you'd find that if it's a service line, a Gemina service line, they can put a meter inside each of the retails. If that's not going to be possible because it doesn't meet Gemina guidelines, then you'll need to allow in a meter room, a VBM room, to install more gas meters and run separately to each of the retails. So it's because the retails use a fair amount of gas, they nearly always want freedom of choice of a gas supplier. And if they get locked into one, no matter how cheap it is, they get upset, and that affects the value of that tenancy in itself. So a lot of the developers will say, if we can run a separate gas supply into each retail, that's what I'd prefer. Now, the hot water infrastructure, there's very, very little difference between a centralised plant being used for a serviced hot water provider and one that's not. They're very, very similar, but basically a lot of the embedded suppliers, and you'll probably find there'll be more and more from the ones that I've spoken to in the last few weeks, their frustration with dead legs is starting to become a major issue. And a lot of them are looking at the code from 2018, and they're really pushing for that to go ahead on service jobs. Some of them even have it written into their contracts with the developers that it must be recirculated down each apartment and a hatch be put in front of each apartment door with a meter installed just inside that hatch, because I'll run through it a little bit later on, but there's some serious issues, especially in New South Wales with dead legs. The only other thing that may be different is the EN providers require check meters for gas and cold water just to gauge the efficiencies of their plants. That could be the only difference from a standard setup. Now, your responsibilities as a designer, well, really a lot of it doesn't change, but when you're looking at a design, the question should always be asked, and because serviced hot water in New South Wales really it's only a few years old. A lot of people may not have been exposed to it. The simplest thing is to ask the builder or the developer if they have an embedded network hot water offering, and to ask for the contract details in regards to matrix of responsibility. Because if you don't, you might end up designing a system that you're going to have to change. And the last thing you want to do is spend double the time on anything that we do these days. We're all cutting it down to the bone. So obtaining the requirements that may be specific to the contract between the developer is important. Hot water reticulation on each floor as an example. As well as that, to consider the EN hot water providers are different from that traditional Gemina design with a maximum gas pressure. So we've seen several jobs that have been designed at 5 kPa, and when we've said, listen, no, there's no meters in this site, we need 2.75 everywhere as a maximum gas pressure. And they go, yeah, not a problem. You say, well, are you going to go back and look at your gas design because you've just dropped your pressure down by nearly half? And they go, well, why do I need to do that? And we've seen several systems that have been undersized and have gas flow issues because of that drop in pressure. Again, going back to this dead legs, while it's not a requirement yet, considering the consumer and how long dead legs will affect them for the life of the building. Consumer complaints on lead times are the most prevalent ongoing issue for every embedded network hot water provider. As soon as everyone walks away from that site, the phones start ringing. I am waiting so long for hot water. And the largest examples of dead leg wait times are all in New South Wales, and they all go between 2 and 3 minutes every time that hot water is cooled down. It takes 2 to 3 minutes to get hot water through the tap again. We understand it happens, and we are trying to approach as many people as we can to say, listen, can you have a look at it? Because if you don't, the government will do it for you. The consumer complaints and ombudsman complaints are getting so great for long lead times for hot water in New South Wales that the government will probably seriously look at changing it. And whether they change it for to suit the consumer before it suits the designers, maybe we need to start acting a little bit now, so to avoid those complaints down the track. But there's some sites in New South Wales where you just can't fix it, not without spending a lot of money. We also have, with embedded hot water services in buildings where there's multiple services being offered, like a residential section and then a serviced apartments or hotel in the same, or buildings supposed to be supplied by the same hot water plant. In some cases that would have been done previously, but you'll find with an embedded supplier, they'll say, no, we don't want to get involved in serviced apartments. You really should have a separate hot water plant and gas system for that. I mean, in most of the cases that I've seen where there is serviced apartments, and Harry Triggenboth from Meriton, he had quite a few. He's currently looking at bringing those serviced apartments back into the rental pool so he can do long-term rentals on them. And they're now updating the systems to make sure that they all comply with a standard embedded network. So, so leaving meters in there or designing meters in there could be a good thing, even though they won't be built. I know Harry, he now asks for it, so he has that flexibility. Basically, if these apartments require gas, they can also be unmetered and just charged a gas cooktop fee. But if you've got serviced apartments, that bill is paid for by the manager or the owner of the serviced apartments anyway. So it's not a major issue, and it saves, in a lot of cases, if you have under the old Gemina system, if you had a meter in there, the daily service fee is probably very similar to what would be charged for unmetered gas, where with a meter, they also have to pay for the gas on top of that daily service fee. Rightio, has anybody got any questions? Well, that's simple.
Yeah, there's a couple of questions, if no one's going to jump in. So the first one was, do you accept HBox installations? If you remember, we had a presentation last year, face-to-face, on the hot water system with some balancing valves that circulates the hot water through each apartment. Is that something embedded network providers are looking at and would consider using?
I think you'll find that some of them will. I mean, there is a cost factor involved. And normally the embedded suppliers say, we own the hot water plant, we own the hot water meters, all the infrastructure is owned by the developer / builder and then the owners corporation. So it's basically considered that part of the building is the owners corporation's responsibility. If
they put an HBox in that, so you're saying you guys, the embedded network might supply the hot water heater and the meters,
yep.
but the HBox, if they had one, would be purchased by the plumber and maintained by the body corporate, not by the embedded network provider. But they would not be opposed. They wouldn't be opposed to it because there is technically more heat loss in the system, but it obviously reduces the dead leg issue or gets rid of the dead leg issue. So
I think there has actually been some embedded suppliers around the country that have spoken with body corporates and said that their only solution really is to look at putting in a HBox and getting it installed. Because there were some sites in other states. There was one site that, due to some really poor design, they had nearly a 4-minute lead time for half the building.
Okay. And is there, one of the questions in here from a Queenslander actually, Mr. Patton, minimum dead leg time recommended. Do any of the embedded networks have, you said that it's becoming a big problem, but have any of them actually written down a recommended minimum literage or time frame? Or
WinConnect saying their contract with the developer that they recommend a maximum lead time of 30 seconds to the most disadvantaged fixture. Now, they understand that can sometimes be difficult, but it's a recommendation because on some sites you'll find every floor has, especially if it's just got a riser cupboard at one end of a passageway, there will be 2 or 3 apartments or even more that are waiting in excess of 60 or 90 seconds by the time the water is mixed. The prime reason they say 30 seconds came from the 4.5 years I was at WinConnect and talking with customer service. When we do investigations, we realised that people started complaining a little bit after 30 seconds, a lot more after 45, and if they were waiting 60 seconds or more, the complaints were very high and regular. So we understood that, the thing is we've got to look after, sorry, when I say we, I no longer work for an embedded network company anymore. I start Monday with a company that supplies the embedded network companies. But customer satisfaction is a huge thing, because what the embedded suppliers hope for is at the end of their contract, their 10-year contract, they will get re-signed for another 10 years and replace the plant and go through it all again. If they've got a lot of customers that are complaining about a problem that can no longer be solved by the embedded network supplier without a massive cost, and like a lot of these sites, you might find every floor would need a H-box to solve the problem, you know, or every second floor, depending how it's designed. But it's not just that, it's the installation bits. You know, all the ceilings are in, everything's done. You know, it's very large costs. For the sake of some very simple changes at the early stage of the design, they could be solved. I understand the designers are under a lot of cost constraints, and I understand that a lot of designers are doing work for the plumbers as D&C, and really the goal is one thing, and that's to cut as much of the guts out of it as you can. But really, if it doesn't change, the government will change it for you.
I think the 30 seconds.
So,
my question, sorry, it's Carl. Again, Greg.
How you going, Carl?
Not too bad, Greg. Is there a point where the embedded networks will end up basically saying to a customer, you're being a sook, 20 seconds is an okay time to wait, or 30 seconds or whatever? We've had a few clients where they're starting to put in their briefs for, one had 14 seconds, another one had 18 seconds, and we've had another one that is sitting at 22 seconds, and we're going, that's not really practical. I guess, like you said, that they start the complaint in 30, but do you get many complaints below the 30?
There's always some. There is always some, and the main thing is you've got a lot of people these days that are moving from apartments, are moving into an apartment from a house where the hot water plant was directly outside their ensuite bathroom. They turn on the tap and 3 seconds later they've got hot water. I've had multiple examples of that in Queensland, where I used to make a habit of ensuring that every single complaint in Brisbane I went to look at myself, to find out where the problem really was, and to explain it in layman's terms. That you now live in an apartment, you do not have a hot water plant sitting inside of your apartment taking up space. It runs outside your apartment somewhere, and then there's a dead leg that runs into here. A lot of the time it's to get through the emotion of their argument too, because I had somebody at a site at Gasworks say they were waiting 3 minutes for hot water, and by the time I got there and discussed it with him, he was actually waiting about 34, 35 seconds. But when you're standing there buck naked with your hand underneath the cold tap, 35 seconds feels like 3 minutes. And when you're angry about it, well, it escalates even more. So getting through the objection to find out what the fact is probably one of the hardest things that the embedded suppliers have. That's why I used to like to go out to site to get through the emotion of their problem and actually get to the fact, because then you could say to them, listen, you moved from a house, haven't you? And they go, normally, yes. And I go, you don't have a hot water unit sitting outside your ensuite door anymore. And once they understand the facts, 100% of the cases here in Brisbane, they understood it. Normally their wives would have a crack at them and say, you're an idiot, stop complaining and go and have a beer. In fact, nearly every case the wife told them to stop being an idiot. So it's 30 seconds I think is fair. I live in an apartment block in Brisbane, and I wait about 25 to 30 seconds. It's not a long time to wait. It's just their expectation, the customer expectation. You have to manage that. But if you've got suppliers up here saying that it has to be a maximum of 18 or 20 seconds, I'd be looking for another embedded hot water provider. Wind Connect, they say 30 seconds is what they want. But we've got jobs in Sydney that go well over that. A lot of jobs in Sydney.
Greg, while we're here, we've found in our Melbourne office, almost all of their jobs in Melbourne are having that flow and return down the corridor, like you mentioned before. So you've got your hot water meter located in the ceiling directly outside your unit. Is that similar in Queensland?
Yes.
Yeah.
I mean, there's changes, but Origin, who did most of the embedded hot water systems up here, it was actually in their contract. I know there's people that are trying to change it because, especially on DNC, we're talking a fair bit of extra copper. But we found that it reduces complaints on sites where we've got a flow and return down each passageway with a hatch and a meter out the front of every apartment. We get next to zero complaints.
Yeah.
The only problem we have is when our dear friends, the plumbers, install the systems, they've got no idea, and I'm not saying this is a generalisation, but they don't know how to commission the balancing valves.
Right.
And that's something that really needs to be looked at too, and hopefully Wind Connect or some, I am trying to look at putting together a embedded network industry association to look at sponsoring the HCAA's hot water commissioning centre.
Yeah, okay.
But realistically, it's there's simple things to fix.
But imagine you can't exactly mandate that.
No.
And say you have to have the meters in the ceilings.
Yeah.
I know we've come across a couple of projects where you start looking at those things, and of course the safety and design issue comes up, saying, oh well, you know, you've got a meter up at high level, no one's allowed to walk, you know, up a ladder that's at 1.2 meters off the ground anymore, even though that's kind of what you do as a plumber. Have you had any obstruction like that in safety and design issues before?
Never.
I mean,
it's been mentioned, but
I mean, it's metered remotely anyway, right?
Yep.
You only got to get up there and service the meter once every couple of years, maybe.
Well,
if that.
If there's nothing wrong with the meter and we believe it's reading accurately, it'll stay in there for its life without getting touched, which is it's 10 to 14 years. So, and that's the thing. And then when we do replace them, we're not normally replace. When I say we, I'm talking the embedded suppliers. They'll go in and probably replace the lot, because if one's on its way out, then chances are they'll all be on their way out.
Yeah.
So it'd be a coordinated work site.
Because the alternative is, like you said, if you've got people designing things, when you're saying 3 minutes, I can only assume there's one hot water cupboard in a long corridor serving, 15 units or something crazy.
Yep.
I mean, I can't believe people are even contemplating that. For something like that, we would break that up to a maximum of 5 units per hot water meter cupboard.
Yeah.
So you would end up with sort of typically 3 or maybe even 4 meter cupboards in a long corridor, so that you're only servicing a small group.
Yeah, a lot of it comes down to a tricky design where you might have an apartment down the end of a passage, which is a long, skinny apartment. The ensuite is at the very front of that long, skinny apartment, and you might have a 20 or 30 metre dead leg. And of course, the ensuite being the most likely unit where they're going to stand there buck naked with their hand under a cold water tap, and it happens. So what really should have been done is either that line should have been heat traced, or a recirculated line of some kind put down that passageway and back. Those pumps that Grundfos were showing today, perfect for little setups like that. You could sit there and just put a pump into a hatch and just run it at a very low rate, purely just to keep that dead leg. And for the sake of one apartment running a 20 mil line down a hallway and back, it's not going to be hard.
Another one we've come across in the past with Gemini, when we had a very long penthouse like that, they would put in 2 hot water meters and combine the totals, and that would end up on one bill. Like, would an embedded network do the same?
Definitely. Wind Connect have been doing that for years. They only charge them 1 daily service fee, but to make sure that they haven't got a long dead leg. And of course, people who live in a penthouse are normally the first people to complain if they have to wait any period of time. That they'll run 2 meters into that penthouse, and I know that Wind Connect have got multiple sites across Australia where they're doing that.
Thank you.
Yeah, Greg, we do it differently here in SA. We actually, I've been here listening to your dead legs issues, and look, we have very little issues here at SA, where we basically don't run things down corridors. We take them up internal service risers. So you have a short dead leg from the meter, which is actually inside the apartment. Because they're all pulse output, there's no requirement there for anybody actually to access those meters. But it means that all the dead legs are very short, and we generally wouldn't get any complaints from any apartment owners, let alone penthouse owners. And if a penthouse dead leg would exceed meters, we'd probably actually introduce an extra meter as well.
Yeah, Paul, that used to be the case in most places, and up here in Queensland, a lot of the sites were internal risers, short dead legs. One of the biggest problems for embedded hot water suppliers is what happens if somebody decides not to pay their bill? If you've got a riser with a meter internally, you can't shut off their hot water, and that's the problem. And I'm not saying in South Australia is the case, because all good things come out of South Australia, including me. But in certain locations across the country, I'm trying to be politically correct here, but there may be large populations of the building that could be under lower financial gain than others. And what the embedded suppliers have found that in that site, on a particular site, lots of people stop paying their bill when they work out that nothing can be done to stop them from using the hot water. And then it just becomes a legal issue. And if somebody talks to somebody else and says, I haven't paid a bill for 12 months, I'll just keep on using hot water, they do it, and then it becomes legal. So the embedded suppliers always prefer to have somewhere where they can actually turn off the hot water supply. And I know that down the track, it won't be too far away, there will be an electronic solenoid that will be possible to do that.
Greg and everyone else, that used to be the case in Queensland, but the acceptance of AS 3500 2018 actually prevents you from running circulating hot water within the units now. It's got to be accessible from the communal space. So I don't know if anyone else has run into that, but that's now what's causing us to run it in that central core area and not what you've done in South Australia, which is the way we used to do it in Queensland.
I think when technology changes and meters can be turned off remotely, I think that'll be easy to go back to that. But I think you'll find that with so many apartments across Australia now having, or especially large scale apartments having embedded hot water providers, they need to have access to be able to disconnect. And that's not possible when the riser's internally, unless you sneak your way in, which has been done in a couple of sites that I know of, saying that the hot water meter needs to be serviced. And when they get in there to the hot water meter, they lock off the handle and put a chain on it and then walk out and say, pay your bill. Any more questions?
I don't have a question. It's Larissa here, WinConnect. Just didn't want to interrupt your presentation, Greg. I think you gave us a very good insight and summary of centralized hot water and embedded networks. So thank you very much. In relation to dead legs, just a few comments from my end. You mentioned heat tracing, which can be a solution. However, we're receiving lots of complaints in relation to heat tracing systems. If it's metered to a tenant's electricity meter, their electricity bill is obviously quite high. And even if it's metered from the common area supply, we are receiving complaints from owners corporations. Just something to keep in mind when you look at heat tracing. Another thing is with dead legs or cheap hot water designs, something that might really help is if hydraulic designers can just provide some information on expected lead times. So once designs are submitted and discussed in the builder tender phase, these concerns can be raised. So we might have the opportunity to revise designs and make them better before they are being implemented. And the last thing I wanted to mention is WindConnect is actually currently implementing a residential and commercial project for one of our clients where we are supplying and installing the H-box in cooperation with Wooden Greaves. So we're definitely looking at that.
Thanks, Larissa. Well, there you go, fellas. There's your HBox job in New South Wales. So,
a thought popped to mind there too when Larissa talked about it. If we can prove with these water meters that we've got in, which we pretty much have proven, that the flow rates are a lot less than what we're currently designing to, particularly with hot, the block of units that I monitored in Newcastle for 2 weeks, the heat loss we calculated on that building was about $6,500 a year. And by sizing that pipework, or reducing it from 100 mil down to about 40 mil for the flow rates we monitored, the heat loss dropped to about $4,000 a year. So based on that, companies like WindConnect might be willing to throw some money at the water meters we're looking at putting on, specifically on hot water systems, and then saving money and complaints in the future on on hot water usage.
that's a great idea, Nick. I think you should have a chat with Larissa about that. So.
Yeah, but that sort of popped in because I do think we will be able to significantly reduce pipe sizes, and this all we're trying to do is verify that our thoughts are correct. So thanks a lot for speaking tonight, Greg. If anyone has any other questions, email them to us, and we can let Greg know, or Larissa, was already working with Greg, but she's sort of taken over Greg's role. If you guys need to contact someone for some embedded network advice.
Hey Nick, one more comment.
Yep.
There's two good apps. One on the phone, which is called Deadleg, which you can calculate the deadleg length in PEX pipe, copper tube, stainless steel, and whatever else you want. Also put your tap flow rate in there, so it'll calculate your wait time as well. So it's dead spacebar leg. And then there's another good piece of software out there on the market called H2X, which is more of an engineering-based software, which will also schedule out all the dead legs and calculate the wait times for you in each apartment. So both of those are one's free, the app, and the other one's commercially available from the H2X website.
Yeah, I'm just there's the dead leg app. I'm just pulling it up for everyone to see. Let's move across. I don't know if is that screen share. No, it blocks it out. It's all right. I did have it installed on my phone before, and it does work well. So, okay. So next week is the Adelaide meeting. So with all of these meetings, they're free to anyone at the moment. Next year we may make them members only, but at the moment anyone's welcome to dial in, and the intention is that if you want to dial into the Canberra meeting, the Adelaide meeting, or the Sydney meeting, doesn't matter where you are in Australia, you're welcome to attend. And there's still no word on whether we're going to go back. We still would like to have face-to-face meetings in November, but we'll just inform you guys in another 4 to 6 weeks on where we're at as far as face-to-face meetings go. So that's probably about it. So if you haven't booked your tickets for Adelaide, dig out that email from a few weeks ago or go to the website and just find the link to the Adelaide meeting and book yourself a ticket. I think that was, sorry. Yep, so that's it. So thanks everyone for coming along tonight. And if you've got any questions, flick them through to us and we'll do what we can to answer them for you. Thank you.
Thanks everyone. Thanks, Nick.
Thanks, Nick. Thanks, guys and girls. All the best.
Thanks, Greg.
Yeah.
Yeah. Bye-bye.